Welcome all to Sangam Tutorials Gubbi online classes for 10th standard Ncert and Cbse mathematics and science classes. So in today's class, in this session, that is 30th session, we will be going with polynomials of chapter 10, which is very important. In the last session we had discussed regarding the basics. So we had learned what are variables, we had learned what are constants, how a term is formed, how an algebraic expression is formed, how we get a polynomial, and what is the main difference between an algebraic expression and a polynomial. So all polynomials are algebraic expressions, but all algebraic expressions are not polynomials. Why? The reason you know that, because if an algebraic expression has to become a polynomial, the exponents or the powers of the variables involved in the algebraic expression should be non-negative integral exponents. In the sense, they should be whole numbers. If this rule applies for an algebraic expression, sure it is a polynomial. So until this we had in our last session. So in today's session we will be going with a very important topic, that is the types of polynomials. Let us go with some examples. So we know that in a square all the four sides are equal. In a square all the four sides are equal. If the area of the square is some 36 square centimeters, then find the side of the square. Maybe a very simple question in front of you, you have studied in your previous classes. So if you consider that the sides of the square is 8 centimeters, 8 centimeters, 8 centimeters and 8 centimeters, then area of square can be given as, that is side into side, that is area of square is given, that is 36 is equal to, let one side be x centimeters, so x into x is x square is equal to 36. So if you look at this algebraic expression, also a polynomial, because x is the variable and the power of that variable is plus 2, therefore this is an algebraic expression as well as it is a polynomial. Now, so if you bring it to the standard form, x square minus 36 is equal to 0, this becomes a algebraic, that is, which is in the standard form, because we have made RHS equal to 0, therefore it is in the standard form. So here we observe that for the variable x, the degree involved will be 2 here. So there are two terms here, x square is one of the term, minus 36 is another term, and it is equated to 0. Okay, no problem. So x square minus 36 can be called as a polynomial only if you do not consider this equal to 0. When you consider only x square minus 36, there are two terms in this, and the variable is x and the exponent of x is plus 2. So here this is an algebraic expression in two terms and also a polynomial in two terms. Therefore these type of polynomials are called as binomials. In the sense, it is having two terms in it. I can go with some more examples. Y square minus 10, z square minus 45, again x square minus 40x plus 1. Okay, let us only take binomials, right? So these are all the examples for binomial algebraic expressions, and also polynomials. In the field of polynomials, they are called as binomials. Now, if you consider this polynomial, here the variable is y, so it is a polynomial in y. That is how we call it. So here the variable involved in this polynomial is z, therefore it is called a polynomial in z. So here in this polynomial the variable involved is x, therefore we call it as the polynomial in x. So here we can represent this, or this is okay, we write polynomial in y. This is a polynomial in y. This can be written as p of y is equal to y square minus 10. So this is how we can represent the polynomial. Here p stands for the identification of the polynomial. We identify that polynomial through p, and inside the bracket we have y, and this y indicates which particular variable is involved in that polynomial. So here P of y is y square minus 10 means y square minus 10 is the name given, that is p, and the variable involved in that polynomial is y. Therefore, it is P of y is y square minus 10. Let us go with this. So it's a polynomial in Z. So this can be written as Q of Z is equal to Z square minus 45. So here Q represents the name of the polynomial and Z represents the variable involved inside the polynomial. So it is x square minus 40x. So it's a polynomial in x. So this can also be given a name like this: R of x is equal to x square minus 40x. So here R represents the name of this polynomial and x represents the variable involved in that polynomial. So these are all called binomials, right? We will go with another type of polynomials, that is trinomials. We will go with trinomials. Tri stands for 3. Nomials goes with the number of terms. So x square minus 3x plus 10. So this is a trinomial, because trinomial, that is a polynomial which is a trinomial. So here I can call it as a polynomial because x is the variable here, x is the variable here. It appears at 2 places. Though it appears at 2 places, the coefficient, that is the exponent of x is plus 2 here and exponent of this x is plus 1 here. Therefore it's a polynomial. As this polynomial has 3 terms inside it, therefore it is called a trinomial. So here the variable involved in this polynomial is x. Therefore I can give a name, for example, t of x is equal to x square minus 3x plus 10. So t is the name of the polynomial. To identify that polynomial, we keep this name, and in the sense we keep this alphabet here, and x is the variable involved in this. So next is, rather take another example, root 3x. So root symbol is only for 3, not for x. So plus 9x square plus 11. So this is another trinomial. It's an example for a polynomial which is a trinomial. So we can give a name for it. S of x is equal to root 3x plus 9x square plus 11. So this is a polynomial, and it's an example for a trinomial. You can go with this again. P 10p square minus 7p minus 11. So this is another polynomial which is a trinomial. Here the variable involved is p. So that if you call it as the polynomial as s, this can be written as s of p is equal to 10p square minus 7p minus 11. So s is the name of this polynomial and p is the variable involved. So s of p is a polynomial. So this is an example for a trinomial, polynomial which is a trinomial. So let us go with another category. For example, I have 3, I have 6, I have minus 11, I have minus 21, and I have 0. So what about these? Because they are all single terms. What can we do with this? So these are called as constant polynomials. These are called constant polynomials. So here I can write it as p of x is equal to 3, it's a constant polynomial. P of y is equal to 6, it's a constant polynomial. P of z is equal to minus 11 is a constant polynomial. P of m is equal to minus 21, it's a constant polynomial. So these are all the examples for constant polynomial. So a very special case here is if p of q is equal to 0, this polynomial is exactly equal to 0, therefore this is very specially called as a zero polynomial. So if any polynomial is equal to a constant 3, 6, minus 11, minus 21, 100, 200, minus 300, 4000, 5000, something like that, they are all constant polynomials. If and only if a polynomial is equal to exactly 0 only, then it is called a zero polynomial. It's very, very important. So that is a polynomial in 2 with 2 terms is called a binomial, a polynomial with 3 terms is called as a trinomial, a polynomial with a single term that is equal to a constant is called as a constant polynomial, and in that constant polynomial, if the polynomial is equal to exactly 0, then it is called a zero polynomial. So in the next session we will go with the degree of the polynomial. So before entering into the degree, now we are in a position to identify and learn the standard form of a polynomial. Let us go with that. So this is the most important concept, as we went with the standard form of an AP in the previous session, that is a plus d, a plus 2d, a plus 3d, dot dot dot, a plus n minus 1 into d. That was the standard form of an arithmetic progression. So likewise, we have a standard form of a polynomial also. So let us go with this. So here, p of x is equal to, p is the name of the polynomial I am going to write, and x is the variable involved in the polynomial. So x base 0 plus a1 x1 plus a2 x2 plus a3 x4 x3 plus a4 x4 plus dot 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 plus an x to the x base n. So this is the standard form of a polynomial. So here, let us go to this. This is a base 0. So a base 0 means it is a constant. You remember this? A base 0 is a constant. A1 x1 is nothing but it's the term of the, or else I can go with this. A1 x to the power 1. A2 x to the power 2, A3 x to the power 3, A4 x to the power 4 for better understanding. So A x to the power n. So this is still more convincing. So A base 0 is the constant. A1 x1 is the term which is in the form of 3x, 5x, minus 8x, minus 10x, plus 11x, plus 200x. Those terms is represented by A1 x to the power 1. So a2 x to the power 2 represents 3x square, 9x square, minus 6x square, minus 100x square, something like that. A3 x cube represents ax, that is 3x cube, minus 4x cube, minus 100x cube, minus 200x cube, something like that. So this represents 9x to the power 4, 20x to the power 4, minus 100x to the power 4, 3 by 2x to the power 4, something like that. And an x to the power n is the general form of each and every term of the polynomial. Okay, so here let us go with this. A base 0, a1, a2, a3. Let us not take this, let us take this one. So a4, a5, dot 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 until an are called numerical coefficients. They are called as numerical coefficients. So now here again x to the power 1, x square, x cube, x to the power 4, dot 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 until x to the power n. Okay, are called variables. With positive exponents. Okay, and again here a base 0 is called constant. Constant in the sense it is 3, minus 7, 6, 8, which is without a variable with it. So for example, I will tell you here it's a constant. A1 is a constant, A2 is a constant, A3 is a constant, A4 is a constant, An is a constant. These are all constants, but a base 0 is the real constant because this a base 0 is a single number without any variable attached to that. Therefore, it is called a real constant. These are all just constants because they are involved with the variables. This A3 is involved with variable, A2 is involved with some variable, A1 is involved with some variable. It is with variable. Here it is a number, a constant which is without a variable. Therefore, it is the real constant. So, a base 0 is constant, which is a real constant. Okay. Numerical coefficients or constants. Okay, you can also use the word here. Okay. So here, a base 0, comma a1 x to the power 1, a2 x square, a3 x cube, a4 x to the power 4, dot 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 dot, an x to the power n, or terms of the polynomial. This is very important. Terms of polynomial. This is very important here, right? So once again, so this is the general form or standard form of a polynomial. A base 0 is called a constant. A1, A2, A3, A4 until An, they are all numerical coefficients or constants. They may be positive or negative. They may be any real number. And then x to the power 1, x square, x cube, x to the power 4, x to the power n, they are all variables with positive exponents, because if they want to be entire algebraic expression has to be a polynomial, then the powers or exponents of the variable should be non-negative integers. So, non-negative integral powers, that is, they should be whole numbers. So here they are constants. A base 0 is the real constant, and a base 0, a1 x1, a2 x square, a3 x cube, they are all the terms of the polynomial. So in between the terms you may have positive or that is plus sign, or you may also have minus sign. So next we will go with the examples where we are going to check out whether the given expression is a polynomial or not. Now we will go with the next part of polynomials, where we will be going with this question here. Which of the following expressions are polynomials? If not, give reason. So if it is a polynomial, no problem, just we will write, we will analyze the problem and just we will write it as it is a polynomial. If it is not a polynomial, we have to write the reason for that. So here we are dealing with those polynomials having variable 1. That is, we are going with polynomials having a single variables or same variables, right? Okay. Let us go with the first one. 4x square minus 3x plus 7 is there. So here we can observe that in this 4x square minus 3x plus 7, we have the same variable everywhere. We don't have x here and y here. That's the meaning of my words. Here x we have the exponent of x is plus 2 here. The exponential value of x is plus 1 here. So therefore it is a polynomial. So it's a polynomial in x. Okay. So let us go with the second one. So y plus 2 by y is given. So y plus 2 by y is there. So y plus 2 into y to the power minus 1. This can be written like this. So here we see that variable y has minus 1 as exponent. So here y is having plus 1, but this y has minus 1 as exponent. So therefore it is not a polynomial. So this is how we have to give the reason. Okay, let us go with the third one. 3 root x plus x root 2. So I hope you can write it in the that is exponential form. So 3x to the power 1 by 2 plus x root 2. So here root symbol is for 2, not for x. So therefore x has the coefficient 1 by 2, that is the exponent 1 by 2, which is not a whole number. So we see that variable x has 1 by 2 as exponent which is not a whole number. It is not a whole number. So therefore it is not a polynomial. So this is how we have to answer this. Or else in the starting itself we can write it is not a polynomial, then write the reason. So let us go with this one. X to the power 10, that is y to the power 3 plus t to the power 50. So here we can see that as we are dealing with the polynomials only with a single variable, here we can see that there are three different types of variables involved. One is x, another is y, another is t. So here there are more than one variable. There are more than one variable, so therefore it is not a polynomial. So this is the solution for this. So it's very important. Now we will go with the next very important topic on polynomials, that is called degree of a polynomial. Now let us go with this. For example, I have a polynomial p of x is equal to x plus 1. So in this polynomial p of x, x is the variable and the degree of the polynomial p of x is, you have to look at the variable x and see the power of it. So if the power of the highest power of the variable involved here is x to the power is 1. So therefore the degree of this polynomial is 1. So here if you want to check the degree of any polynomial, you have to look at the variable, and if that variable has a positive value, that is positive exponent, it's a polynomial, no doubt in that. How much it has, that is 1. Here in this example we have the exponent value as 1 of that variable, therefore it is called as a polynomial. A polynomial of degree 1. A polynomial of degree 1 is also called as a linear polynomial. So you have to remember this. So it's also called as a linear polynomial. So what is linear? Linear stands for 1. So here, what is the degree of a polynomial? So the highest value of the variable involved in the polynomial will be called as the degree of the polynomial. So p of x is x plus 1. So polynomial it's degree 1 because the variable x has 1 as the power, therefore it's degree 1. So if a polynomial has degree 1, then it is called a linear polynomial. So let us go with the standard form of this. So when we come to the standard form, we can write this as a base 0 plus a1 x to the power 1. So p of x is equal to, so this is the standard form of that. P of x is equal to a base 0 plus a1 x to the power 1, where a base 0 is the constant, that is 1, and a1 x to the power 1 is 1 into x to the power 1. So a1 is 1 here, x to the power 1 is x to the power 1 here, and a base 0 is 1 here. So this is usually what in the standard form, standard terms we go, or in your textbook it is also given as p of x is equal to ax plus b. So this is also the standard form of a linear polynomial, where a stands for 1, x stands for x to the power 1, and b stands for 1. So this is the standard form, this is also the standard form, but which type of usage is used in your textbook? This or this? Actually this is not used, this will be used. So therefore the standard form of a linear polynomial will be ax plus b. So here one more important thing is, a linear polynomial may be a monomial or it may be a binomial. For example, p of x is equal to x, I will write and just keep quiet. So this is also a linear polynomial, no doubt in that. So p of q of x is equal to, we write another polynomial. So q of x is x plus 3. So this is also a linear polynomial, this is also a linear polynomial, because the degree of x is 1, here the degree of x is 1, but here in this case it is a monomial and in this case it is a binomial, both are possible. So therefore there are two possibilities here. So what is a linear polynomial? A linear polynomial is a type of polynomial which has degree 1, in the sense it's the highest value of the exponent of the variable present in that polynomial is 1. Therefore it is called a linear polynomial. Linear polynomial can exist in two different forms. It can be a monomial or it can also be a binomial. So let us go with a quadratic polynomial. So let us go with some examples here. Let us consider another polynomial. P of x is equal to x square plus 2x plus 3. So this is another polynomial. So here in this polynomial there is x, so it's a polynomial in one variable, and the highest value of the exponent of the variable present is, here for x we have 1 as the highest, that is 1, and here for this variable x we have 2 and 2. So therefore we have, out of these two we have to consider the highest value. So here the highest power of the variable present is 2, therefore it is a polynomial. It's a polynomial of degree 2. It's a polynomial of degree 2. So therefore a polynomial of degree 2 can also be called as a quadratic polynomial. It's also a quadratic polynomial. So let us go with the standard form of this. So we have to remember all these things, which is very important. So we will go with the standard form. So I hope you can identify the standard form here of x square. It is a2 x square plus, we can identify this a1 x to the power 1 plus, we can identify this, that is a base 0. So this is the standard form of is equal to p of x. Okay. So this is the standard form of the quadratic polynomial. So what is given in your textbook? So it is something like this, or p of x is equal to ax square plus bx plus c. So this is also the standard form of a quadratic polynomial. So a quadratic polynomial can exist in three different forms. For example, p of x is equal to just x square. It's a monomial. It's a monomial as well as it is a quadratic polynomial because the highest degree of the variable is 2. Therefore it is a quadratic polynomial. Again I will take another example. Q of x is equal to x square minus 3x. So it's a binomial. So highest power of the variable involved is 2. Therefore it is a quadratic polynomial again. So or it can also be written as r of x is equal to 3x square minus 10. So this can also be possible. So then we will go with another one. M of x is equal to x square, that is 3x square minus 2x plus 10. So this is also an example. So it's also a quadratic polynomial which is a trinomial. So it's not, don't keep it in your mind that only trinomials can form quadratic polynomials, nothing like that. A monomial can also be a quadratic polynomial, a binomial can also be a quadratic polynomial, and a trinomial basically will be a quadratic polynomial if the degree of the variable involved will be exactly 2. So this is a quadratic polynomial, right? Okay, we'll go with another type of polynomial, that is a cubic polynomial. So if the highest degree of the variable involved in the polynomial is equal to 3, then it is called a cubic polynomial. So let us go with this. So p of x is equal to x cube plus x square plus x plus 10. So this is an example for a cubic polynomial because it is a polynomial in the same variable, it's a single variable. So the highest degree of the variable involved is 3, therefore it is a cubic polynomial. So let us go with its standard form. If you go with the standard form of this, you can write it as p of x is equal to, I hope you can identify this, a3x cube plus a2x square, this one, plus this can be written as a1x to the power 1 plus this one can be written as a base 0. So this is the standard form of a cubic polynomial. So also this can be also written as, so p of x is equal to ax cube plus bx square plus cx plus d. So this is also the standard form of a cubic polynomial which is being used in your textbook. So in between the terms you may have plus sign and minus sign, that depends on the polynomial. So a cubic polynomial can also be a monomial, it can also be a binomial, it can also be a trinomial, and that is a particular term, that is a polynomial with 4 terms also. So for example, if you write p of x is equal to x cube, this is also a cubic polynomial. If q of x can be written as x cube plus x square, then also it is a cubic polynomial because the highest degree is 3. R of x is equal to x cube plus x square plus 3x. This trinomial can also be a cubic polynomial because the highest degree of the variable involved is 3, and m of x is equal to x cube plus 4x square minus 3x plus 10. So a polynomial with 4 terms can also be a cubic polynomial. So only thing is the highest degree of the variable should be equal to 3. So this is a cubic polynomial. So let us go with another type of polynomial, that is biquadratic polynomial. This is a biquadratic polynomial. So here bi stands for 2, quadra stands for 2, so therefore 2 plus 2 is 4. So if a particular polynomial is involving a variable with degree 4, then it is called as a biquadratic polynomial. So I will write the polynomial, for example, 3x to the power 4 minus 3x cube minus 2x square plus 4x plus 8. So this is an example for a biquadratic polynomials. So here the numerical coefficients involved here are all real numbers, and no particular real number is equal to 0. That is, a base a is not equal to 0 anywhere here, and this is the condition for a polynomial to be defined. So 3x to the power 4 minus, this is a biquadratic polynomial. So we will go with the standard form of this. So standard form of this can also be written as p of x is equal to, I hope you can define this, a x to the power, that is a base 4x to the power 4, a 3x to the power 3, a 4x to the power, a 2x to the power 2, and a 1x to the power 1, and a base 0. So here this represents this term, this is represented by this term, this is represented by this term, this is represented by this, and a base 0 is constant represented by 8. So this is the standard form of a biquadratic polynomial. So a biquadratic polynomial can be of terms monomial, only monomial, or binomial, or trinomial, or a polynomial with 4 terms, or a polynomial with also 5 terms. This is the possibility. So let us go with another type, that is a constant polynomial. This is very, very important. So most of the problems you are going to come across this. What is a constant polynomial? So if a polynomial p of x is equal to a number, is equal to just a real number, then it is called as a constant polynomial. P of x is 3 is a constant polynomial. P of x is equal to minus 10 is a constant polynomial. P of x is equal to minus 100 is a constant polynomial. So here, if these are constant polynomials, then what is the degree of these constant polynomials? The degree of a constant polynomial is always 0. You have to remember this. Degree of constant polynomial, degree of a constant polynomial is always 0. So you have to remember this. This is very, very important. So it will be asked for 1 mark in your examination. So what is the degree of a constant polynomial? The degree of a constant polynomial is 0. So now also we have 0 polynomial. We have 0 polynomial where the polynomial p of x will be equal to exactly 0. If a polynomial is exactly equal to 0, then it is called a 0 polynomial. So now, what is the degree of a 0 polynomial? The degree of a 0 polynomial is not defined. Remember this, degree of a 0 polynomial. Degree of a 0 polynomial is not defined. This This is very important. So degree of a constant polynomial is 0 and the degree of a zero polynomial is not defined. So these are the different types of polynomials and different possibilities and their standard forms we have discussed. I hope this session you enjoyed this. It's very important. Write down the notes, be updated, and the worksheets, answers what you are sending to me through the WhatsApp. Please don't send just answers to me. Send me the entire process what you have done. So you are doing a fantastic work. Keep up the work. Right? I wish you all the best for that. So stay home, stay safe, and keep learning.